where if you would like to get up and grab a cookie or more lemonade or another enchilada, you can feel free to do that. But since we're on such a tight time frame, I'm going to do my introductions and have a seat so we can get this conversation going and you can spend your time wisely. So on behalf of the Institute for Public Policy and Social Research at Michigan State University, welcome. Really glad to see you here on this cloudy, sunny, rainy day. We never know what's going to happen out there, but it's the right day to be in this room, right? Today we're going to talk about Michigan's response to PFAS. My name is Anne Marie Schneider, and this is about my 27th year in doing these public policy forums. And this year, not unlike years before, we've really had a full house on all of our topics. So there's been a good bit of news on PFAS and PFAS recently. In fact, these chemicals have received national attention as a real problem in our water and in the environment in general. So we're going to have somewhat of a speed course, a refresher course, an up-to-date course, depending on where you are on knowing about these chemicals. Very quickly, I want to tell you that this form ties up the series for the year. And this forum series, as I said, it's run about 26, 27 years, so it's truly a part of my legacy at Michigan State University. And many of you have been there with me on most of the forums, so thank you. Whether this is your first or one of many IPPSR forums, thank you for being here and making an effort to stay on top of the issues at the forefront of Michigan's policy agenda. So I want to encourage you to keep learning about this topic even after today and sharing information. We're going to focus on quite a bit of research, so you'll have that going for you, and you'll have that for a conversation piece. We have all of our forum materials, including the ones from today, posted on our website. And that's for your reference. For ones not for today, obviously, but we have the videos of the forums that we've had throughout the year. And we've covered a good many topics that are still being discussed. Even from last year, there are a few topics like vaccination waivers that we've featured. We featured redistricting last year, and it's still in the conversation, very much in the conversation. For this year, you'll see not only materials, but you'll see experts listed for line 5, the separation or the interaction of oil and water in the Great Lakes. You'll hear about, or you'll read about recidivism strategies. How can we keep offenders, ex-offenders? We also talked this year about aging communities and why that's such a good thing and how we can do that better. We also talked about opioid use and suicide. That's a very relative conversation in our national agenda. We talked about term limits and prevailing wages. We also talked about recreational marijuana use. So check it out. I know that as you come across those topics, we want to have that resource there for you, but we also want that network available to you. So all of our panelists throughout the year, including the folks who are here today, want to be of help to you and want to have those discussions with you. They want to exchange information, so perhaps you can help them stay on top of things as well. So today we have, again, an outstanding panel of experts. We have Lois Wolfson. I'm going to be really brief on the introductions, and so you have full bios there at your table, and you can fill those, or you can take a look at those. We also have evaluation, so if you need to sneak out a bit early, take a look at that evaluation, help us out and fill it out. Today we have Lois Wolfson, who's a senior specialist of outreach at MSU Extension. She's also affiliated with the Department of Fisheries and Wildlife at Michigan State and the Institute of Water Research. She's going to talk with us a bit about the background on PFAS in the environment. And then Cheryl Murphy will speak to us. Cheryl is an associate professor with the Department of Fisheries and Wildlife at Michigan State. And Dr. Murphy will talk with us. She'll provide an ecological risk assessment on PFAS and the environment. Steve Sliver is the executive director of MPART, Michigan's PFAS Action Response Team, a rather new position with the Michigan Department of Environmental Quality, or is it EGLE now? EGLE, Department of Environment, Great Lakes, and Energy. So if you heard it here first, you're a little late. Susan Maston. Dr. Maston is a professor and associate chair for undergraduate studies with the Department of Civil and Environmental Engineering at Michigan State. She's also a member of the Michigan PFAS Action Response Team, and she'll speak with us about remediation strategies and further research needs in order to manage this effectively. And finally, we have Josh Gunn, who's an associate director for the Community Food and Environment Institute at Michigan State University, and that's part of Michigan State University Extension. So very happy to have you here. And we're missing one panelist, but there you go. I think we're all set. Dr. Wolfson, would you like to kick us off? Thank you. This is your.
Okay, great. There we go. Okay. And I have my phone here. I'm going to start my timer so I don't go over. Thank you, Anne-Marie, for inviting me. And it's nice to see so many people here interested in PFAS. So I'm going to talk, as she said, a little bit about the background on PFAS in the environment. It's going to be very quick, and then we'll turn it over to other panelists that will talk more about what's going on in the state of Michigan. So PFAS chemicals, synthetic man-made organic compounds, they're known as per- and polyfluoroalkyl substances. There's thousands of them. In fact, the Chemical Abstract Service Registry lists about 4,700 chemicals. But what's similar about all of them is the carbon-fluorine bond. And the two that we're most familiar with, the one we've heard most about, and the ones that were used most often in various products are the PFAS, and you can read the scientific name for it, or the chemical name, and PFOA. And I wanted to point out these are the chemical structures for them, and what you'll notice on them is that they have carbon chains of 8 carbons and then surrounded by the fluorine atoms. And why that's important is because they are no longer being used and they are being replaced by what are called replacement short chain chemicals, Gen X for PFOA and PFBS for PFOS. And these are shorter chain chemicals and they have different properties. So what do we know mainly about PFOS and PFOA? One, they're persistent. They do not break down easily within the environment, and that's why they're known as the forever chemicals. That carbon-fluorine bond is one of the very strongest bonds in nature, and it would take something an incineration temperature of over 1,100 degrees centigrade to break down those bonds. They're also different from other organic chemicals. They don't bind to lipids, but they bind to proteins. And so they're found more often attached to the albumin in the blood, and they're also found in organs like the kidneys and the liver. They're reabsorbed by the kidney, which gives them a longer half-life because they're recirculated into the blood. And the estimated half-life for people is anywhere from 2 to 9 years. It depends on the chemical and the person. It's much less than animals in days and in months. They're easily dispersed throughout the environment. They are found in soils, in groundwater. They have been found in remote places around the world, in the Arctic, the Antarctic, the oceans. Even polar bears in Greenland have been found to have high PFAS levels in their liver. And one of their properties, they repel water, oil and grease, and that's why they were so good in the products which they were used. Now, these shorter chain PFAS chemicals are less toxic. They bioaccumulate less, but they're still rather persistent within the environment. So these chemicals were manufactured starting in the 1940s and manufactured and used up till the 2000s, and slowly they were phased out, and now they are no longer used within the United States, at least the PFAS and the PFOA and a couple of other of the chemicals that we're looking for right now that are within the environment. However, they still may be used on an international level. They had their properties help them in all these different products like stain resistant fabrics and carpeting, in waterproof clothing to repel that water. They were used in packaging for foods like microwave popcorn bags or fast food wrappers to keep that grease and oil within the package and from leaking out of the package. As you probably have heard, they were used in firefighting foams, mainly on Air Force bases and at airports, and chrome metal plating for protective surfaces. People can be exposed to them by numerous ways, but the two main ways are through drinking contaminated water. That could be either from private wells or municipal systems, eating fish that have been in water contaminated by PFAS, but it also could be from other animals as well. There are some do not eat health advisories. You should check the Eat Safe Fish Guide or the MPART site from the Michigan Department of Community Health and Human and Health Services. Right now, there are do not eat advisories in the Oscoda area for parts of the Au in Washtenaw, Oakland, and Livingston counties for parts of the Huron River and some inland lakes, and a couple of other counties as well. There are some other pathways where PFAS can be taken into the body, accidentally swallowing dust or oil, not oil, or soil, eating food that had previously been packaged with those fast food wrappers and such that had PFAS chemicals in them. There's less known about plant uptake and how that plant is taking up the chemical and whether it's residing in the roots and their leaves or the tissues or the fruit or the eating edible parts of the plant. The absorption through the skin is negligible, and so if you touch water that has PFAS in it or if you're in soil that has PFAS, the chance of getting it absorbed through the skin is not very high. There are numerous potential health effects. You can read what they are here, but they're based on various studies. Some of the studies are done with animals, and as I mentioned, animals excrete PFAS much quicker than humans do. So we have to look closely at taking that information we get from animals and moving it on to that's going to be an effect on humans as well. But there have been some studies with people where people have been exposed long-term to PFAS, people that have worked in the manufacturing industry where PFAS was found. And those people have been studied and have there's been results showing increase in thyroid disease and high cholesterol levels in those people. And then there was a settlement suit between DuPont and people from the Ohio River Valley. 59,000 people were tested. And so some of these results are based on what was found with those groups of people. The CDC has looked at the blood levels of numerous people and have found 4 different PFAS chemicals in the blood, and these are the ones listed. And what we can see is that there is a decrease over time, but it's still rather high in terms of the levels that are being found in the blood. And it's thought that at least 95% of the US population has some level of PFAS within their blood. The EPA has set a lifetime advisory health level of 70 parts per trillion for PFOA and PFAS combined. And that lifetime advisory level, that means that's how much a person could ingest on a daily basis over their lifetime without adverse health effects. This is not law, this is an advisory. So you might say, well, what is a part per million? And a part per million, or not million, trillion, a part per trillion If you took an Olympic-sized pool and then took 20 of them and combined all that water and put one drop in those 20 pools, that would be 1 part per trillion. And so you say, is that even important? Or is it significant? And the answer is, if you have a chemical that is persistent, that is bioaccumulative, and toxic, then yes, particularly with long exposure times to that chemical, that is a significant amount. And so some states have said 70 parts per trillion is still too high, and they have lowered their levels. New Jersey just recently lowered it from 40 parts per trillion down to 14 for PFOA, and then Vermont down to 20 parts per trillion for 5 different PFAS chemicals. And then finally, if PFAS is found in home drinking water systems, there are some water treatments that can remove the PFAS from the system. This is for home water use at the point of use, not necessarily at the point of entry. And the 2 types of treatments are granular activated carbon and also reverse osmosis. What was formerly the National Sanitation Foundation, which is now NSF International, certifies filters for use for removing PFAS, and they, on their package, is listed that it's certified to either this standard or this standard to make sure that these are filters that can remove PFAS. And then finally, I want to leave you with the thought that you should never boil PFAS contaminated water. And the reason that is that it doesn't vaporize, at least PFAS doesn't, PFOA does to some extent, but it will just concentrate the chemical. So this is my contact information. I think it's in the folder as well. And we're going to wait till the end to ask questions. So thank you very much.
All right. So thank you, Lois. That was a great introduction. And so what I'm going to talk to you about is, because as you see, we don't know a lot about PFAS or PFOA or PFAS in general. We're trying to figure out, we have a group at MSU and through Ag Bio Research trying to figure out how can we respond to the PFAS problem from an agricultural and biological perspective. So I think this works, right? Aha, there we go. Okay, so we have, what we're doing, we have this group, we're trying to figure out what sort of questions can we ask so that we can figure out what is the risk of PFAS to our fish, our wildlife, to our agricultural products. And basically, we know what we're looking at here is there's tons of ways that PFAS can be transported through the environment, from the atmosphere, soil, wastewater treatment plants, biosolids. What we're concerned about is how is getting into our natural resources, like our fish and wildlife resources, and our agricultural products that eventually lead to the human exposure there. And just for an example, this is what came out from Fish and Wildlife Consumption Advisory Committee suggested. Here's some in the Osable River. This came from the Michigan DNR. We have they've been issuing do not eat advisories for a lot of fish because they're thinking that this is how the PFAS is going to get up to the humans. And there's you can see that like largemouth bass and coho anytime there's largemouth bass, you have a do not eat advisory. Rock bass, do not eat advisory. And so anything with PFAS is getting a do not eat advisory, whereas the other chemicals we're getting like dioxins and PCBs, we have a limit. We have a little bit more better understanding of why. What we can put a 6-year effect on it or whatever. But with PFAS, we don't necessarily know exactly what the implications are yet. It's also being found in deer. This happened last year in Clark's Marsh. They found a deer with really, really high PFAS levels. And so they had to issue an advisory because it was taken near 5 miles of Clark's Marsh. That's where the military base is. And so they had to issue an advisory. We want to figure out what we want to know is how is PFAS going through the environment to our fish and wildlife, and then maybe if we can figure out what's going on, then we can have better understanding of the advisories and know exactly what to target. So we have to figure out The exposure pathways, we need to figure out how it's being biomagnified in the food web, what its biological effects on the different taxa out there, and we have to have a good understanding of risk. And so in order, we have to do a sort of a risk assessment. Basically, how you do a risk assessment is, first of all, you have to figure out what the effects are from exposure. So what is the biological hazard of being exposed to PFAS? We have to figure out where the pathways of exposure, and then the combination of the effects and exposure will give you an idea of risk. And so basically, just to reiterate that, so basically it's when the biology and the exposure, when they intersect, that's when you have a high risk of exposure, and those are the areas that you want to look at and target with your research. Okay. Now, so first off, in order to tackle these questions, we have to look at, first thing is exposure assessment and characterization. How these chemicals bioaccumulate, bioconcentrate, biomagnify is really uncertain. And they're really unusual. They're not like our normal PCBs or mercury, because PCBs or mercuries, we know they bind to lipids, and the older and bigger you are, the more of that you're going to have. But these are binding to, they're becoming in bass that are in the middle of the food chain, and they're not necessarily the largest fish around. And so they're really unusual. They have a really unusual bioaccumulation and biomagnification pattern. Probably because they bind to these proteins and also the membrane phospholipids. So every single cell has this membrane around it, and they're binding to that phospholipid membrane, okay? They don't bind to the storage lipids as well. They can be metabolized, but we don't really know what the mechanisms are of metabolization. And also these next generations of PFAS have not really been studied, and there's thousands of them. There's a trend towards increasing bioconcentration and biomagnification with increasing carbon lengths. So you saw the 8-chain lengths. So we have some shorter chain lengths. Those don't tend to not bioaccumulate as much, but we still don't really know. There's over 4,000 of them or more, and some of them we haven't even identified. And so we have to figure out what their effects are. So this is quite a big problem, actually. And toxicity occurs after you get exposed to contaminated water, soils, and food. Okay, so what we need to do is we need to get some standards for PFAS. We need to get some standards for identifying them, and we have to identify some of these unknowns. There's some of these chemicals that are out there that we don't even know what the structure are. We need controlled laboratory or semi-field dietary biomagnification studies on fish, mammals, avian species, and various plants. We need laboratory studies where fish are exposed to contaminants just through their diet and not through respiratory uptake from the water through their gills, because this will give us an idea how biomagnification occurs. We also need experiments that expose mammals like deer, mink, to background levels of PFAS in drinking water and food. And we also need similar experiments in birds as well, because birds are being affected, especially all those waterfowl that are mucking around in the foam in the lakes. We need to determine the elimination half-life for all these different PFAS. We have we have to figure out how the food web is structured and how it's moving through this food web. And basically, because there's so many different chemicals, we have to develop models, because that's the only way we're going to be able to tackle this question, is we have to get some exposure models built for contaminant fate and transport. And so for the biological effects from exposure, so we have the exposure, now we go to biological effects. This is the hazard of ecological risk assessment. So we need to determine the hazard to biological life. And many of these effects are not lethal. They're not going to directly kill the organism, but they have these sort of long-term population health because they affect reproduction, they affect growth, they affect immune function as well. And they rarely occur in isolation. They also occur with other legacy contaminants, like methylmercury and PCBs. And because the way PFAS binds to the proteins in the cell membranes, it could actually amplify the effects of these other legacy chemicals that are out there. So there's like a multiple stressor effects there. So, but we don't really know. We have to do this. So one way to do it is this thing, which is really jargony. We call it an adverse outcome pathway. Basically, sorry, it's a little, I guess the font is not big enough, but basically what you're looking at is you're looking at a molecular response, and you're trying to figure out how that molecular response translates to up levels of biological organization, to cellular, organ, individual, the whole individual, and then a population response. And the reason why we want to do this is because we can do these things at the molecular level really, really well. Like it's cost efficient, and we can just expose, we can do through 96 well flights, high throughput exposure. But then we have to link it up to these population responses, like individual responses, because that's important for ecological risk assessment. We have to know how the population is going to respond in the long term. So this is one way to do this, and it's probably the only way we can really go tackle this question because of there's over 4,000 chemicals to do. So we need to test on molecular and cellular levels of the biological organization to determine the potential toxicity pathways. This is relatively inexpensive. You can use in vitro and in silico approaches. And then this mechanistic information will inform how will interact with these other stressors like PCBs and mercury as well. If you have a good understanding of the mechanisms, you'll be able to see how these multiple stressors will affect. And then we'll link to the adverse outcomes that can be interpreted at the population level for ecological risk assessment, because to do a whole population study is really, really expensive and time-consuming and challenging. So many of these PFAS have been run through EPA ToxCast, which is a program that the EPA has to determine these molecular and cellular responses, but they have to be linked to population models calibrated for Michigan fish, wildlife, and agricultural resources. Through these models, we'll need representative fish, amphibian, avian, and mammalian models, and we have to do this for thousands of these chemicals. And then once we have this set up, we'll be able to respond to future stressors and multiple stressors as well. So this is just an example of an AOP. I know it's jargony, but just to quickly show you. So basically, we know that PFAS intersects with this PPAR alpha receptor. This is I know jargony, but this is like an AOP. It hits the molecular effect. It hits this receptor, and basically it cascades all the way through. We get circulating ketone bodies to increase muscle protein catabolism. And then eventually what that means is we get a decrease in the body weight. And this is a population level effect that we can use in our models. Okay, so we need to fill in these links here. And so basically that's it. What we need to do then is we need to figure out, once we have the biological effects from exposure and the pathways, we can then figure out risk. Okay, and I'd like to acknowledge our working group. We have a PFAS Ag Bio Research working group, and then we've worked with Tammy Newcomb and Ag Bio Research, and that's my contact information. Thank you.
All right, good afternoon, everybody. There we go. Okay, let's jump right into it. Thanks very much for the opportunity to be here. And PFAS, when did that become an issue in Michigan? Well, you know, we knew about it up at Wurtsmith Air Force Base back in 2012. And we started looking around in Michigan in some of our waterways, and we weren't really finding it. But then over the past couple of years, it became obvious it wasn't really an isolated issue, that we were finding it other locations across the state. And so Michigan took a first in the nation unique approach and said, you know, given what we've heard about some of the concerns with these chemicals and the possibility of where it might be across the state, the need to coordinate is huge, we created MPART. And this is a multi-agency approach with all the agencies that are involved in environment, health, agriculture, natural resources, even our military and veterans affairs, fire marshal, and MDOT, because of installations that use firefighting foam where PFOS, PFOA might be involved. And this MPART really is, you know, I've been a bureaucrat for 32 years, and it's almost like a confession. MPART is breaking down, has broken down those silos across agencies. It's the only issue that I've ever observed in state government where we have all agreed to cooperate and coordinate our efforts because it requires that much of a cooperative arrangement. And basically, MPART is coordinating our strategy on a statewide level, working with local partners and federal partners as well. We are trying to be as transparent as we possibly can. One of our goals is to inform the public and work with stakeholders and other states through either national associations and or us going out and visiting them. We were in Minnesota. Many of you know Minnesota has had issues for quite some time. We went there and said, what are you doing? What have you learned? This is what Michigan's doing. We're all trying to learn from each other. And I want to highlight here on the advisory work groups, MPART has the ability to establish advisory work groups. And right now we are working on, I think, a really critical one, and that's a citizens advisory work group to help us better understand how to communicate with the public at large, keep the affected communities engaged, and really, an environmental health education component to make sure that the right message is getting out on the risk of these compounds and what we're doing about it. So this slide really is just to show when you're dealing with an emerging contaminant, you start at ground zero. And MPART has been coordinating with industry and all the agencies and federal partners, even to come up with standard protocols to sample different media so that you can analyze it. And what are the analytical methods? And all the way to, at the end of the day, after we have a better understanding of the science and the occurrence of these compounds in our ecosystem, developing the regulatory structure. I like this slide here, the PFAS cycle. We've talked a little bit about this because it really illustrates the challenge that we have with PFAS in our ecosystem. And essentially, cycle is the word. We are cycling PFAS compounds throughout the ecosystem because we're not effectively destroying them. They are so persistent. The landfill is the best example there, where so many consumer products and other industrial waste go into a landfill, and the landfill collects leachate off of these waste over a period of time. That leachate goes into a wastewater treatment plant that's not effectively removing PFAS because it's not set up to do that. It ends up back in the waterway and the fish, the biosolids that go back onto agricultural lands, potentially into the drinking water. So that's our challenge, and MPART is a multi-agency approach to coordinate that. So Michigan, we've got 49 sites, and I hear people say, wow, you've got that many sites, you got more sites than anybody else. Well, the reason we have 49 sites is because we're looking. We are aggressively looking, we're identifying sites, prioritizing where we look, and when we find a site, and these are sites that are defined through the MPART group as those that exceed 70 parts per trillion of PFOA and PFOS in groundwater. And as soon as we find a site like that, we immediately investigate private residential wells and other drinking water sources down gradient. And if we find contamination, we immediately get those folks on alternate water. We're continuing to look. I don't know how many we'll end up with. Will we have 100? Who knows? But again, the point here is we probably have the most comprehensive approach of any state in the country on trying to identify these sites and to reduce the exposures once we found them. We have integrated PFAS testing into our surface water protection program, whether it's looking for it in our ambient water testing. We know that you could have up to potentially 2 parts per trillion of these compounds, and you're going to find that in many waters. But when you start finding more than that, that indicates you've got a source, and that will lead us to go identify where that release is occurring. We have integrated it into fish testing to identify sources longer-term effects in our surface waters. And you've heard about foam, and we are investigating foam. We know it's on surface waters that have contamination with PFAS, and how do we address that? We're working with our partners to come up with ways to first and foremost accurately sample it, and then to actually remediate it. Longer term, get it out of the water. And our industrial pretreatment program, we are identifying sources of PFAS getting into the wastewater treatment plants, which, as I said, aren't really effective at removing them. And we're being effective there, taking thousands of parts per trillion of PFOA, PFOS, and industrial discharges, bringing them down to non-detect. There's a lot we don't know, and so we are promoting research in a number of areas. I mentioned earlier the biosolids. What's the impact when you apply biosolids for agricultural purposes? What is the effect on soil and groundwater and surface water? Landfill leachate. Landfills have coordinated a first-in-the-nation study of concentrations of PFAS in leachate, and now that's leading us to work together to find out what are the best solutions for mitigating those concentrations longer term. And treatment technologies. Treatment is very limited. The options are limited, and so one example of what MPART is doing is this Friday, May 10th, we're holding a PFAS treatment technologies roundtable over at MSU to bring in experts from around the state and the country to say what research is needed, and who can do it, and ultimately we hope that will lead to a treatment technologies conference here in Michigan. Public water supply testing, just want to highlight here that we tested over 1,700 supplies in Michigan last year. First state in the country to take that comprehensive of approach, and the results were relatively good. 90% of our public water supplies had non-reportable levels of PFAS. And only 7% had something a little higher than that, but less than 10 parts per trillion total PFAS compounds that were analyzed, 14 to 24 of those. And so 10 parts per trillion, what's the magic of that? Basically at this point, there was recognition within MPART that we probably didn't need to go out and aggressively pursue a source if we were down below 10. But we had 62 supplies, or 3%, that were in what we call the middle bucket. They had a little bit more than 10, but they were less than an action level of 70 parts per trillion you heard about. And so those we are, at this point in time, doing an investigation of potential sources and monitoring for whether those levels go up or down. Talked about the public health advisories coordinated through MPART and local health. And again, DHHS is working on doing some health exposure assessments in areas that had impacts more out of the norm than what we've seen across the state. And we're working on prevention as well to make sure that we aren't causing problems with firefighting foam going forward. I want to say that we're able to do this because Michigan has some standards. We've got standards enforceable for surface water and for groundwater. We don't have one yet for drinking water, but as many of you know, Governor Whitmer announced a couple of months ago that we are going to pursue that. And here's one of the reasons that she said that she wants us to pursue it in 2 steps. She wants us to first get together a group of scientists to advise us on what health-based values should be used for setting an enforceable standard in drinking water. And this is just one example here, PFOA. The numbers across the country, 9 to 78 parts per trillion. We're asking some outside experts to advise us on where do we start before we plug those numbers into a rulemaking process, which will also look at things like feasibility, what can you actually analyze for, what's feasible in public water supplies. Our goal from this timeline, as you can see, is to actually have enforceable drinking water standards in Michigan by next April. And you'll likely read and hear about many other states are taking their own approaches as well, because we aren't getting that sort of leadership out of EPA. They have a process to come up with standards probably in several more years than what we're doing. So Michigan is moving ahead, and that's very important for longer term integrating the PFAS testing into our drinking water supplies. All right, thank you.
Thank you for the opportunity to be here. I'm going to talk a little bit about treatment and remediation, a little bit more details than, than what we've talked about before. Got it here. I'm awake. Okay. As mentioned before, PFAS is a large group of chemicals, somewhere over 3,000, over 4,000, approaching 5,000 chemicals. I added this slide to kind of give a comparison between the PFAS chemicals and PCBs. We tackled PCBs back in the 90s. There's only 209 congeners of PCBs. Solubility is relatively narrow compared to what you see in terms of the solubility with the PFAS chemicals. So in terms of fate, transport, remediation, it's far more complicated to deal with the PFAS chemicals than it was to deal with PCBs. Like PCBs, they're recalcitrant. The carbon-fluorine bond is a stronger bond than the carbon-chlorine bond, so it's even harder to break that carbon-fluorine bond than it is the carbon-chlorine bond. The octanol water partition coefficient is really measured to the degree to which that compound wants to bind to organics. And this is a log scale, so it's 10 to the 10 to the 1 or 10 to the 3. So we're talking about high degree to which that compounds bind to the organics. And vapor pressures vary. They can be lower molecular weight compounds, can have much higher vapor pressures. Your longer chain compounds will have lower vapor pressures. That impacts whether it's going to be in the water or the air phases. So in terms of remediation, it's been mentioned a couple times in terms of what we have. We really only have 3 different methods for remediation. We have granular activated carbon. So this is, if anybody has a fish tank, that's the black granules that you see in a filter in a fish tank. It's highly absorbent, so chemicals that don't want to remain in the water, so the chemicals that we call hydrophobic, will tend to bind to activated carbon. The lower molecular weight compounds that aren't quite as hydrophobic aren't going to bind as well. So typically when we use granular activated carbon, it has what we call a short life, or a much more rapid breakthrough than what you would see with a compound like PCBs. Also, other chemicals in that water can impact the efficiency. So if you have other organics present that compete for those sites on the carbon, you're going to get lower removal efficiencies. We have ion exchange resins. Most of these compounds are ionized, so they're, for the most part, negatively charged, so they can be removed on an anion exchange resin. And then we have reverse osmosis, so you've got a very tight membrane, high pressure, and you're looking at separating the chemicals from the feed water. Problem with all of these, we've got some sort of a waste stream. With activated carbon, we have the spent activated carbon. What do we do with that? With ion exchange, if we regenerate the ion exchange resin, as you would do with a softener if you had a softener in your home, we have regenerant solution. If we have reverse osmosis, we have what's referred to as the concentrate, because we're essentially separating that chemical from the water. And that, in an RO system, that concentrate can be 50% of your feed solution. So how do we treat those waste streams? For private wells, again, options in terms of treatment are limited. MDHHS recommends that if a water contains PFAS in excess of the 50 part per trillion, then that water should not be provided to infants, should not be used for washing produce, and shouldn't even be used for brushing teeth. The whole concept is to minimize exposure. There are certified filtration systems. These filtration systems are only certified for PFOA and PFOS. There is no certified system that's certified for all groups of, all that whole plethora of compounds. As mentioned before, it was the NSF international standard. That has been retired. It was retired in 2019 and replaced with an ANSI standard, the American National Standards Institute. We have point of entry. We can talk about both point of use and point of entry. Point of entry is a system that is put at, essentially, think of it at the meter, okay? It's put at the entry point to the house. So you're looking, it's a whole house treatment system. Typically, there's some sort of a pre-treatment that may be filtration, there could be a softener, but basically what you're trying to do is remove anything that would decrease the efficiency of your activated carbon. Typically, these are activated carbon systems. Once that carbon is exhausted, so you've used up all the sites, what do you do with it? Right now, about the only thing we have is incineration, and it's incineration at a temperature in excess of 1,000 or 1,100 degrees C. We don't have an incinerator in Michigan that operates at that temperature. After, you can put in a post filter. That post filter can be for biological removal, and then a UV filter again for biological control. Point of use, these are units that are put on the filter, on the faucet itself. They can also be under the counter. Under the counter filters, there are GAC, there are some ion exchange, there are fewer, and then there are also reverse osmosis. Reverse osmosis, those waste streams are going to go into the sewer system. Again, as mentioned, as Lois mentioned, you don't want to boil water that's contaminated with PFAS. In terms of wastewater, this was mentioned before, wastewater treatment was never designed to remove these types of chemicals. It wasn't designed to remove PCBs. It's not designed to remove PFAS. There is some removal, and if it is, those chemicals are then in the biosolids. So there's concern about movement of these chemicals from the water into the biosolids. It's just a wastewater treatment scheme. I'm not going to spend a whole lot of time talking about this. So basically, we do have some movement of some of these chemicals into the biosolids from the primary sedimentation, some from the secondary. If you're looking at removal of PFAS chemicals, you're looking at further treatment. This tends to be expensive treatment, and you're looking again typically at granular activated carbon or RO filtration. Again was mentioned, PFAS and leachate. PFAS chemicals were ubiquitous. They're used everywhere. They're not surprising that they're in landfill leachate. This is a study across the U.S., but levels found in Michigan in landfill leachate are similar to what you see here. And then in terms of treatment, we've got basically those same three treatment processes. We've got activated carbon, we've got reverse osmosis, and then we've got an ion exchange. All of them have their benefits, they have their attributes, they also have their issues. One of the major issues, as I've mentioned, is competition with other chemicals, and then the other is what do we do with the waste streams. Contaminated soils, we have excavation and incineration. That has to be done, incineration would have to be done outside of Michigan. We have capping and monitoring, talking about a long term, and then we have short soil washing. I'm not going to spend a lot of time on recommendations. I think I've hit on most of these. For every treatment system that we use, we need to understand what are the compounding effects, what affects treatment, and then we have significant issues to deal with. How do we deal with these waste streams? So I will leave it at that.
All right, Anne-Marie, thank you for inviting me. I'm honored to be surrounded by these experts in PFAS. I am not an expert. I'm in administration with Michigan State University Extension. And so I'm here to talk today about some of the work that we're doing to integrate the research that's being done and facilitating dialogue to continue to help support communities by providing education and resources. Just out of show of hands, how many people here are familiar with Extension, Michigan State University? Oh, this is great. Okay, I'm done. I'm just going to go. I will spend less time on that. But these are just some key points. We're essentially the third leg of the land grant university. We're tasked with doing our performing agriculture mechanical curriculum on campus. We're tasked with conducting research, and that's through the Ag Bio Research Department. And then we're also tasked with extending the knowledge that's being developed on campus out into the communities. So we have a presence in an office in 82 of the 83 counties across the state. We have a programmatic presence in all 83 counties. Our programming is very diverse. We have health delivery in terms of mental health, fitness education. We also do business startup, business entrepreneurship programming. We reach every school system in the state. We have over 200,000 youth that we engage with. And then we also have a volunteer, just in 4-H alone, staff of over 20,000 people. We do rapid response for the Flint water crisis when there's other emerging issues that happen similar to the PFAS issue. We redirect resources, we redirect people, and have them. And then we're also a resource to local government on public policy and budgeting education, which is a often forgotten about part of our programming, but that's actually housed in the institute that I belong to. As I mentioned, we've got, more specifically, we have 273 educators across the state, 145 specialists, 183 programming staff, and then we have investments in over 300 campus faculty. And like Lois is an example of one of the faculty members that we have an investment in, along with others in the Institute for Water Research. The big thing is we live and work in the communities that are being impacted by PFAS. These are when the community is impacted, it's the neighbors of our staff that are impacted. It's our staff themselves that are impacted. Many of our offices, I tried to get a number before today, I couldn't, but because of our partnership with federal, state, and local dollars to fund extension, many of our personnel are housed in county service offices. So many of them already have local relationships with the health department in the county. Just wanted to, before I talk about some of the stuff we are doing, wanted to address the challenges. And Lois, I thank you for reviewing this, because there would have been a lot of repetition if I had if Lois hadn't provided feedback. You've heard from everyone that the health effects are still not well understood. There's some studies have been done on animals versus some that have been done on humans. Bouncing around, I just read a story in NPR that they're estimating for all the PFAS chemical strands that to just catalog them and start grouping them so they can test is going to be about 2 years of research. So how do we address the educational need in our communities when we are uncertain, right? So we're working closely with the research faculty. We have Lois and a couple other educators who are leading this effort to make sure that when research is done or when new policy is created, that we do in service to all of our programs, because we don't just have a PFAS training program. We integrate it with our health programming. We integrate it with our water policy programming. And so how do we provide enough core competency of the knowledge of PFAS in our staff so they can take it and customize it for their own individual programming area? As you've seen I like your graphic about the pathways. Those pathways are a lot of assumptions. We know that that's how things can get transferred, but we don't know the significance of those the transference from one to another. Bioaccumulation in fish is pretty well studied, but there's a lot of other pathways into food systems that we need more research on. And lastly, I think the difference between a health advisory and a legal safety limit is something that's challenging for people, just that I've heard. What is the difference? why is there a health advisory and not a legal limit? Some education and explanation to community members on that aspect is important too. So what has been or is being done? We have an Ask an Expert page on our website, and Lois and our other educators check that regularly. And basically, it's out there for anyone in the country to ask questions, and then they're directed to experts in extension across the country. But Lois is tagged is Eric tagged on that as well? So Eric Elgin, our educator out in Western Michigan, addresses those questions as well. We have regular updates, not only with our staff in our institute, but across institutes. We have research faculty involved. We have representatives from the state of Michigan, agencies involved. I think, Anne Marie, you got my name because we had the PFAS speed meeting, and the speed meeting was our attempt. In Extension, we try to connect the right people together in the room, and so it was just a brief overview, 5-minute presentations from all the different projects across Extension that we're working on. Some of them that were mentioned is, we already have curriculum on lead in drinking water. We already have a curriculum on some other water health issues. How do we take the research that's being done and integrate it into those? We also had a lot of faculty who are doing research on that area there to present on what they're doing. And there was a lot of great discussion afterwards, and I like to think that this kind of venue was, because of what, that meeting that got started. Yeah, the big thing is the state of Michigan has a lot of great resources online, and we're really trying not to mix messages, and so where we can, we're really directing people to the recommendations that are being made by the state on certain PFAS issues. And then, as I mentioned, we are out in the communities. We are in county buildings that have health departments. We can be a resource for researchers in terms of identifying people that might have been impacted or areas that might have been impacted. And then also on the back end of the research where we can help disseminate that. We develop, evidence and science-based curriculum, and then we deliver it, and then we evaluate the effectiveness of that curriculum on changing learning outcomes. So I think I kind of already mentioned some of these. Yeah, so I will just kind of end it there and then wait for questions afterwards. So thank you all.
Okay, well, they did it. They were challenged to stay within 10 minutes to talk about all of the work they're doing with PFAS and PFAS, and they did it. So round of applause to all of you. Excellent. We need to come out to the audience with this microphone because we are filming. We want to make sure that we hear you, and you'll need the microphone to ask your question. Do we have a first question to start us off? There you go. Thank you.
Hi there, thank you. Who does water testing for individuals? And it didn't sound like filters do work, but I'm curious then what filters do work.
Susan, I think you talked.
So I'll take the who does the water testing. So if a resident with their own private well is in an area that we are actively investigating, then we will, based upon the hydrogeology, where their well is installed, what the strength of the source is, do the testing ourselves. So the state will send a contractor out there to do it. And the state as well has done all of the public water supply testing. And actually we're in the next round to do other supplies that aren't considered, the major supplies, but we've got over 1 million private wells in the state, probably have more private wells than any other state in the country. And we've got about 10,000 wells that aren't considered community water supplies, but we want to start testing those as well. So I think we have about 750 that we're working on this year, plus doing more back with the community water supplies.
So then, in terms of which filters work, as just mentioned, there are filters that are certified, they're now certified by the NC standard. Go on to the State of Michigan site, the MPART site, there is a list of companies, or will send you to the NSF site with a list of companies, manufacturers, and specifications for those sites. Typically, they are only certified those for PFOA and PFOS. Maybe a few for a few of the other compounds. There's no filter that's certified for all of the PFAS chemicals.
Let's make sure.
And also, I'm not sure if this is working. Also, if you do go to the NSF International website, they actually tell you what manufacturers are making those particular filters.
Did I answer your question?
Yes, thank you.
Okay.
Can you hear us in the back? No?
Yes.
Yes and no?
Some yes, no.
So what needs to happen, Millie, is we need to call and ask them to turn on come and do the audio. Thank you.
Steve, I have a question for you. If you're ready with your gear there.
I think it's working.
Okay, cool. Could you elaborate a little bit on what MPART and Eagle was doing relative to the biosolids investigation? Are there any preliminary findings there that are directing your efforts? So are there any sites where you found wastewater biosolid sludge has caused groundwater contamination, is a potential concern for agricultural crop uptake, that sort of thing?
Well, sure, I'll try to hit on all of those questions. So we began looking at biosolids in Lapeer because Lapeer's wastewater treatment plant, when we tested their biosolids last year, had some of the highest concentrations of PFOS that we had seen anywhere in the country. And so one of the city-owned fields up there, we knew what the application rate was over time, and so they allowed us to go on there and pull samples of soil, groundwater, and actually it was like perched groundwater, and actually we could also test some of the surface water runoff through drains, and just to get a better handle on what was being left behind based upon application of some of the highest strength biosolids that we had seen. And the crop there that was being grown for ethanol production, corn for ethanol production. We don't know a lot about crop uptake yet, but what we're doing now is the beginnings, I believe, of we can characterize as a study of biosolids much more broadly. We have taken samples from 41 wastewater treatment plants, and I have not seen the data. We had a contractor do that. All the sampling was done at the end of last year, and so we will have that data to give us a better handle, put it all in context. What concentrations are we seeing? We know what the wastewater treatment plants are dealing with, and they're also going out to the fields and collecting soil samples and again more groundwater samples. We haven't seen, at this point in time, it's still a study, trying to just better understand what the occurrence of PFAS are out on these fields where we have applied biosolids over time. So no conclusions yet on what the potential impacts and so I believe that study should be done sometime later this summer.
Very good. Thank you, Steve.
I have two questions. The first one is, as Dr. Master mentioned, we here in Michigan, we don't have an incinerator that can provide over 1,000 degrees C to deal with the used activated carbon for PFAS. As a resident, how we can deal with the waste? This is my first question. And the second question is, when a patient or resident is exposed to PFAS, how we can diagnose them? This is easier to find to proteins. Should we draw the blood or test any organs? Yeah, thank you.
So in terms of activated carbon, as far as I know, private use, the amounts are small. Public use or larger scale use, at this point, I'm not real. I don't want to say, okay? Some cases landfilled, and then you saw that the little cartoon, okay? We're just cycling PFAS around. If we're incinerating, it has to be shipped out of state. And actually, I don't know where the nearest incinerator is that's operates at over 1,000 C.
Okay, does that answer your question? Very good.
Kind of a non-answer.
Well, excuse me, 1 second. We have a question here, and then, if you don't mind, thank you. Oh, I'm sorry, is your question having to do with this response?
She had a second question. Megan has a second question.
Okay.
Who's on the health desk?
Diagnosing?
Diagnosing efficient human.
Good.
I don't think we're at that point yet. To tell if we can diagnose because of PFAS exposure. I don't think we are there yet. So.
With blood levels?
Well, you could take a blood level, I guess.
Yeah, just based on the studies that the CDC did, they were taking blood samples from people and analyzing it. But you'd have to find the place that could do that type of analysis, particularly if they're in the blood, they're at very low levels, hopefully.
So if you go in to have your blood tested, at current time, they're probably not looking for PFAS. Is that correct? If I'm a person who's concerned about my PFAS levels or my water well, and I go in and ask for a blood test to test this kind of thing, that's not happening currently. Right. At a Sparrow lab or, no. Okay. Thank you. And then,
my question is related to the biosolids question. I understand it takes a long time to get these tests back, but it would seem like we could learn a lot about the plants in the same area where there have been biosolids applied frequently. Is anybody testing parts of the plant where it is as they're getting soil samples? Is there any agricultural sampling being done?
it's a short answer.
Okay, sorry. So the sampling that was done this year was, or at the end of last year, I think all the crops were gone. But we did actually take some of the corn plants from the Lapeer fields, and I think those are in storage. Haven't started testing those yet. And I think you'll find even internationally, there's not been a lot of study on that, on crop uptake. But we did collect, and in fact, I think they're at MSU for future study.
I'm sorry. Up here.
Just a follow-up question to how do you deal with the off-gassing from the incinerator?
How do you
I'm just I'm curious, how do you deal with the off-gassing from the incinerator?
So all of gas from incinerators is treated, okay? There are multiple different ways that it can be treated. The attempt with treatment at temperatures in excess of 1,000 or 1,100 degrees C is that you're actually breaking the carbon-fluorine bond, okay? In some cases, activated carbon is used to capture, chlorine, it can be used to capture fluorine. You're still looking essentially limited types of technology, unless you can start breaking bonds and producing chemicals that are not, that are non-toxic, non-bioaccumulated, you're back to square one. And that's the hardest thing with all of these compounds, is how do you ensure that you are breaking all of these bonds, that you're not just volatilizing chemicals and releasing it into the air and then it just gets circulated through the air.
Just want to add to that real briefly, is that from talking with our air quality folks in Eagle, they'll tell us that the first challenge is there's not a nationally recognized protocol for doing the stack test for PFAS compounds. And so that's one of your first challenges right there. Secondly, there's not been any incinerators that have done the trial burns to show that they're effectively removing them. So a lot of this is modeling and understanding of the chemistry. So they've got some questions about the efficacy of incineration. We know it should work, but again, it hasn't really been proven because we're not able to readily test to show that.
Does that sound a little better?
I would like you, any of you, to step back to the 2016 federal law, or I don't know if it was a law or administrative rule about chemicals being developed and how we prevent the very thing that we are experiencing right now with PFAS. It was during the Obama administration, and then there's been movement to perhaps underfund that or undercut it. So where are we at the federal level with that? And what are we doing in public policy and law in Michigan to take us in the 21st century of dealing with chemicals as they are being understood or developed, that we can undo the impact on us in the community? Am I making sense?
You are. I have
One more question. Would you address in utero exposure?
I do have a comment to make. In doing these forums for a number of years, I remember when we started off a conversation about alternative energy. Big topic, alternative energy. What is it? And then over the years, we've gotten to the whole process for building and providing alternative energy, the use of, the big push for, just the minute kinds of definitions you need to really get alternative energy methods or use out there into the public. And I feel like in listening to our conversation today, we're sort of at that level with this kind of problem, that we're discovering this together. There are lots of, each one of our panelists have said, we have a lot to learn. We have a lot of work to do, a lot of science, a lot of research that needs to happen in order to get down to that level of, we've got it handled, right? And so you're part of the process. And we're working through this together. Thank goodness we have such a good level of transparency now that we can begin these conversations early and work through what we need to do to move and become more mature in our response to these kinds of problems. So I just want to say that because I think we're at a, sort of a funky level of figuring this all out. Can anyone respond to what's happening at the federal level?
For the 2016, are you referring to the Frank Lautner amendment to the Toxic Substance Control Act? Is that what you're referring to? Sorry.
You know, I am not knowledgeable enough. I know it was a breakthrough on trying to understand as you're developing chemicals,
Yeah.
the impact and how you mitigate that in the environment.
Yeah, at least I'll just go, on the Frank Lautner, I think it's the amendment to the Toxic Substance Control Act, I think in 2016, where we're allowed to use tests on in silico, in vitro, sublethal, suborganismal types of responses to look at chemicals. And that's a huge step forward for green chemistry, so you can actually screen things before you put them into production at that level, and it's relatively inexpensive. Since that 2016, there's been a lot of, I think the EPA has been working on that sort of procedure for a while, but I can't say how far they've gone. I also think I think the EPA is supposed to declare this as a hazardous chemical at some point. They have that in the works, but they haven't done that yet. So. Right.
Yeah, just one issue with regards to that is that some of these chemicals, even though we've been concentrating on just a handful of them, and we know there's thousands of them, but for example, 3M company replaced the PFAS chemical with these other chemicals way back in 2002, so way before 2016. And then some of these chemicals, there's precursors and there's also derivatives of these chemicals. So yes, we're dealing with ones that have been around prior to that initiative.
And then we had a question about in vitro.
In utero.
In utero.
What do you mean by, what's your? Oh, yeah, I'm not a human health person, so I can't address that question, but it probably will pass through.
Just with what has been found with respect to animals and the people that have been tested so far, there are at least potential health concerns related to hypertension in pregnant women and also with developmental problems with respect to infants and young children. So there is issues there, and there is evidence that there are chances that from, within the uterus that it's going to impact it. Yes.
Maybe some epigenetic effects too. I don't know. We don't, that this could be explored.
So I just want to add to that, I'm not the expert on public health. If you go to our MPART website, and it's www.michigan.gov/PFAS response, you'll see out there a document that our Human Health Work Group in MPART developed, and it's called Public Health Drinking Water Screening Levels. And in there, they go through a rather elaborate explanation of how they came up with screening levels, looking at things like exposure to the fetus and whatnot. So there's some information there that you might find helpful, plus they have a bunch of references in that document as well.
Thank you.
I'm a homeowner in Oscoda, and I've seen the community economically devastated by the decommissioning of the Air Force Base, which was the primary employer for the area. Now we're ecologically devastated by that same base. And I am only a layperson. I see foam washed up on my beach. I kayak in the Osabo River, which is pristine and amazing. And now I see the signs about the fish. You can't eat them. I know that my own personal water comes from in the middle of, I hope it's in the middle of Lake Huron somewhere. I have guests who come to visit me who don't want to drink the water out of the public system there. I don't know how that affects my property value, but I know it affects my peace of mind with my Pure Michigan, because I don't have Pure Michigan up there. I wonder what the responsibility of, I know, again, I read little things here and there, but I don't know. The federal government seems like they ought to be responsible. It's not like companies that devastate Detroit area and then, go in bankruptcy and aren't responsible anymore, right? The federal government should be responsible for what happened up there. I know there was some money, and I know that it wasn't used, and then maybe it got dissipated somehow because we now have lots of other spots in Michigan that need help too. So my question is, the federal government's responsibility in this, what funds are there? What is their responsibility in this? Can they walk away?
Well, we don't have a federal government liaison on our panel, but I appreciate your stab at it, Mr. Slimer.
So, MPART has continued to press the Air Force for more rapid response. And as you're likely aware, the Undersecretary for the Air Force's environmental programs was in Escota a couple of weeks ago and made some commitments, talked about some more interim measures, and our own congressional delegation continues to push for more funds and a more rapid response. So basically not letting that circular process get in the way of progress in the Escota area. We understand the frustration.
We see it day in and day out. It's very difficult.
Yeah, and I think we all want to thank you for the transparency, because as water treatment dealers, it's very difficult to get these questions that arise and not be able to answer them, and there's just so many unknowns. But one of the questions I had was in regard to filtration. We've seen some really positive success with a carbon block filter, and Dr. Maston talked a little bit about this. I'm wondering, you mentioned that there's not a filter that is certified for all of these different versions of this compound. Is that even a possibility? Like, are we years away from that being a possibility with the limitations on testing and that kind of thing?
I mean,
Sorry.
The answer is yes, we're years away, okay. In terms of testing, I forget, I think it's now, it was 14, I think we've increased that to about 25 or 35 or so of PFAS chemicals that we can routinely test for. With solubilities, there are 20 orders of magnitude difference in solubilities across the PFAS chemicals. That's 10 to the 20-fold. That's like to the moon and back, I don't know how many times, okay? It's a significant, it's a significant challenge because of those variability in properties. Solubility, while solubility isn't an absolute measure, it's going to affect your octanol water partitioning coefficients. It's going to affect the efficacy of adsorption to the activated carbon. So yes, while it's effective for many of the compounds that we can detect or that we routinely detect now, there are other compounds that it won't be as effective for. The other issue is, while it is effective, its breakthrough tends to be more rapid, and I don't know what you found, but its breakthrough tends to be more rapid than for many other chemicals. So what that means is you're going to have to replace the carbon more regularly than you would with many other chemicals. So that's a challenge, and it just means you've got more weight, increases your waste stream. And increase your cost because you're replacing the carbon more often. But the answer is yes, we're years from developing something that can identify all 4,000, 5,000, whatever number. They can't even seem to agree on a number.
But we are looking at this problem at all ends, so even industry is looking at how to resolve this problem, to find that happy medium.
The other thing to think about is, and we'll probably get, it was used because it was beneficial. We wanted fabrics that were waterproof. We liked Gore-Tex. In terms of firefighting foams, it was far more effective at fighting airplane fires and saved lives than what was available at the time. So it's a challenge between, you know, what do we as society want in terms of technology, in terms of convenience, in terms of safety. And the human health effects, ecological effects, how recalcitrant it is. Somehow, I'm going to go out on a limb on this one, but somehow we need to have a better way of assessing all of those. And you asked about TSCA. TSCA was never very effective at preventing chemicals that had harmful human or ecological impacts from distribution. It was extremely limited. It was limited in scope, it was limited in funding, and we do need stronger regulations.
Thank you.
I have a question about the Do Not Eat Fish advisory. When that came out last year, I think many people thought that was just temporary, like do not eat the fish right now. But the more that we learn about this and the bioaccumulation and that these are forever chemicals, the more it feels like that's something that's going to stick around for a very long time, which then of course has economic implications. Do you have an idea, you know, are we looking at 5 years of not eating the fish, 10 years, forever?
I think as we put more resources into the research, I think we'll figure that question out rapidly. I mean, it has a half-life, and if we figure out where the sources are coming from and we're able to remediate some of the things, as we move forward with this, I think we'll be able to, I don't know, I don't think it'll be do not eat the fish forever. So that's what I'm saying. Because I think we are actually, once we figure out there's a problem and we put resources towards it, we usually find a solution. So we did it for PCBs, but that's, yeah.
You did it for PCBs.
Well, they did it, I didn't. So.
Thank you. It's a good question.
I'd appreciate, Dr. Marston, you saying what you said. However, the way we operate is that the woman in the back, Southeast Michigan, Ford Lake, we're paying a price. It's that hidden cost that comes down the road, and no one can afford individually, and I'm looking at you because you brought it up, but no one can afford individually to address this on a small scale. And so I think we are at a crossroads here as how we're going to go forward with green chemistry and other things that address the hidden costs of our progress. I mean, we all loved hush puppies, right?
Yeah.
So.
No, I agree with, and
Yeah.
that's why I said we
Yeah.
need to strengthen TSCA.
Yeah.
We need to find ways to balance. We need to find ways to balance our desires, our convenience, our expectations with the human and ecological effects. And we don't have a good way of doing it.
right now?
So I would say to Mr. Sliver, I'm sorry. What are we doing on public policy? What are we doing across the street and administratively to begin to address this at the front end? I know we're not, it's decades, centuries perhaps, but we have to approach this differently. And what are we doing in a legislative environment?
So when it comes to the areas that are covered under TSCA, those responsibilities haven't been delegated down to the states to review chemicals, before they go into the market. What I can say is, really most important right now for the ones that we are looking for, that we are looking for them rapidly, and once we identify where our focus right now is to protect public health. And then, looking more forward, how do we prevent the ones that we know about from getting into the environment? And I think, the firefighting foam is a really good example there. I mean, I went through those slides really quick, but we know that some of those firefighting foams have, the 8 carbon chain compounds that are the most offensive, that we know the most about. And so, the legislature has supported a take-back or a collection program, for lack of a better word, and so we are working on that right now to take over 37,000 gallons of those foams from, the fire departments from around the state. There's over 1,000 fire departments, and 75% of them that responded to a poll. From that response, we know there's 37,000 gallons. The fire marshal is also working with those fire departments to say, hey, if you do have to use the foam, then call Eagle afterwards so that they can make sure that it's been quickly cleaned up and doesn't get into the groundwater. And Department of Transportation has worked with the FAA to enable commercial airports to practice with that foam in a container rather than spraying it all over the field, just to maintain their certification under FAA. So those are some positive steps we can take right now, and it is, basically priorities where we're devoting those resources.
MSU Extension, Mr. Gunn, you have arms in the community and have an education mission. What has struck me about the PFAS discussion nationwide and on the media, is that we focus on drinking water, we focus on poison fish, we focus on the economic issues, but we don't focus on the young mom and dad who's using a Teflon pan to fry the egg for their 1-year-old. Is there any education effort to, teach parents and families what's in their own homes?
Yeah, that is an excellent question. So we have another institute called Health and Nutrition Institute, and I know that they've adopted a lot of PFAS information into their curriculums. Yeah, I'm aware, the chemicals on the frying pans and stuff like that. I'm not sure if there's been testing or research done on the rate of how it comes off or things like that, but they are interested in looking at all aspects, how this affects not just these exposures environmentally, but how we bring it into our household and used in our day-to-day products.
So awareness is first step. So whose idea was it to pull about 200 people in a room and chat about a really tough topic today? I want to thank you for your tough questions. They aren't short-lived. We have this on tape. We have the right people in the room to take those questions to heart and know that those are the kinds of things that we need to look more deeply at, more broadly at, and find answers to. I want to thank the people who are really passionate about this and again help others realize that this is something we're coming in contact with every day. and thank the folks who are doing awareness type tactics, just to let people know about this issue and what we're currently doing about it, but that we're also recruiting ideas on what to do about it and what the next best steps are. So thank you for the folks who are doing the research. Thank you to the folks who fund the research, because that's what will really allow us to dig deep into what's happening here, what the pathways are. Our panelists mentioned pathways for these chemicals and what the real impact is on us, as individuals and our families and our environment. So we're all in this together, and we all have a job to do. And part of your job today is to refer people to our website and refer them to the presentations that have been presented here today. I too am impressed with the state of Michigan's really, I think, assertive, if not aggressive, look at this and asking questions about what's happening, where do we need to test, where is this really heavy duty concentration of this chemical, what can we do about it, how can we work together. MSU Extension just does an amazing job of helping people have that place to go to find general information about how best to protect themselves and to just be aware of what's happening with the issue of PFAS. And so, Dr. Murphy, your work, you have a good many questions, and there are questions that we're all asking, and we appreciate your persistence in pushing that research forward. So, thank you for being here. I know this is a tough time to jump into this ordeal, but stick with it. And I would encourage more forums like this. I had mentioned earlier that all of our forums have been packed to the gill, and we've even had to shut off registration a few times this year. So that says to me that we need more public conversation, and we need some of you to take on extending that invitation, getting the room and bringing some people together and having these conversations. That's how the video that we do, we have this partnership with Impact Media to film our forums. And we're hoping that we have others who have done this before. They take that video and they play it in their community, and they hold discussions right there with the community members. They go to some of the experts that we have listed on the website, invite them into the communities to talk with them. They chat about this issue, or I shouldn't say chat, converse with their public officials about what they learned here today and about what they found on the website. So keep with it. We need you, and again, we appreciate your help so much in making people aware of not only this issue, but all of the things that are being discussed in the policy arena. So, thank you.